Hello, everyone. Good evening to all of you joining from Sri Lanka, Thailand, and anywhere in the world to the webinar organized by IEEE Power and Energy Society Sri Lanka chapter in collaboration with the IEEE Industrial Electronics Society Sri Lanka chapter, as well as IEEE Robotics and Automation Society Sri Lanka chapter. And today, I would like to introduce our esteemed guest speaker, Dr. Thavida Maneewarn. She's currently the founder and director of Raina Robotech Company Limited, a company founded in 2022 that focuses on research and development in agricultural and field robotics. She's also the director of Yannick's Company Limited since 2018. She received master's and PhD in electrical engineering, specialized in control and robotics from University of Washington, Seattle, USA. And then she returned back to Thailand after graduation in 2000. Dr. Thavida began her career as a researcher at the Institute of Field Robotics, King Mongkut's University of Technology, Thonburi, Thailand, where she was promoted as a Deputy Director of Research from 2003 to 2014. And also Dr. Thavida was formerly the president of the Thai Robotics Society and the IEEE Robotics and Automation Society Thailand chapter, which has the mission to promote knowledge and interest in automation and robotics to the young generation in Thailand. From 2007 to 2010, she was also the director of IUCRC HDD, Advanced Manufacturing at KMUTT, which is the collaborative center between the university and hard disk drives industries in Thailand. So she has covered a lot of areas and an expert in this particular area. So today she will present us revolutionizing agriculture by robotics and automation. Without wasting much of your time, I would like to first thanks Dr. Thavida for spending your valuable time with us today, and warmly welcome you, as well as I would like to warmly welcome everyone present here today with us for this webinar. So it's over to you, Dr. Thavida, to carry on your presentation. Thank you.
Hello, everyone. Let me greet you by Thai way. Yes, this is the first time that I have a chance to speak in Sri Lanka. So even though I'm not there in person, but I'm very excited. And today is a good chance that I can give a talk about what I have been doing the last 3-4 years. And I hope that you will share some thoughts, or if you have questions, please ask me. So I will start with my presentation now. So thank you again from the IEEE Power Energy Society and also IES and RIS in Sri Lanka chapter. As introduced before, my name is Thavida Maneewarn, but in Thailand is I actually known by my nickname. So people call me Ajahn Prao. It's Prao is my nickname. So today I will talk to you about how we can change the way agriculture has been done by using robotics and automation technology. So first, let me have a brief introduction about what I did in the past 20 years. So I started working at KMUTT in Bangkok, Thailand since 2000. And I found Thavida Lab, which is my lab, that we built a lot of robots. So we kind of interested in all kind of robots. So in the early days of my career, I built a lot of humanoid robot, climbing robot, and have the robot soccer team. And I did some of the modular robot, like modular snake and the inspection robot, which is has been used in power plants in Thailand. And also we did a lot of this prototype that we built team robot. So from that knowledge, I found that like to be able to make the robot smart and be able to learn, because I spend a lot of time working on like machine learning, especially reinforcement learning, and found that to be able to learn, the robot has to be reliable, has to be robust. So I spend lots of time like designing and building a robot so that it has to be like field test. So we want to test the robot in the field. So I built like a climbing robot, receptionist robot, and then test it in the real environment. So I found that by doing this, it's like to make a real product, we have to spend a lot of time testing in the real environment. And that's why I decided I can no longer be like just a researcher and faculty at the university. I really want to push the product to the end because I want people to use my product. That's why I started a company. So I work at Yanix, which is like a visual effects company. So we do a lot of 3D reconstruction and camera tracking and stuff like that using computer vision technology. And in like today, I would talk mostly about my new company, Raina Robotech, which is the agricultural robotics company. But since you guys are power energy society, so I just want to show a little bit of my old robots that I built. This one is for EGAT, which is electricity generating authority of Thailand.
สังเกตนิดนึงหน่อยนะว่ามันกระพริบ
Okay.
หรือเปล่าคนดูใกล้ๆอ่ะลองตรง
So
นี้มันมองไม่เห็น
so this is the robot that we use to inspect inside the boiler, and it's a climbing robot. So we built a like magnetic wheel type robot. Yes, so to give you guys some idea, so this one we inspect pipe inside the boiler.
Dr. Thavida, like just a small question. I hope it's okay. So any other like what is the environment temperature in this particular pipe that you operate? Is just a room temperature or different?
It's a room temperature
Okay.
because this is inside the
Okay.
boiler.
Right.
So we only inspect it during the shutdown time.
Right.
So the engineer has to see corrosion, like if they have to cut the pipe down and then re-weld it. So
Okay.
that's why we send up the robot. So it's about like 5-story high, like 20 meters up. Yeah. But this one we had a certain type of sensor on the arm of the robot, so it can detect the thickness. So it's the test with like the thickness of the pipe to see corrosion. Yeah. Okay. So, but if you in the future, I can actually talk about the past. This group of work that I did, I call it like a service robot that we did for like pipe inspection and sort of like this one is the boiler. So we did a lot of climbing robot for different type of surface. And this is also another series of the work that I did like commission to people. Is the receptionist robot. So it's a semi-humanoid. So we have like 6 to 7 degrees freedom arms. And this robot, we either rent it out or we built it specific to the client design. Like the rightmost one is the one for the Bank of Thailand. So they put this robot at the museum to kind of teach kids about like banknotes. and the middle one, the pink one, is my first receptionist robot. Her name is Namo. So she's still like operating as the receptionist robot at FIBO. So that's basically my past. Now, move on. So in the recent years, everyone concerned about like how can we make our work be like contribute to sustainable development goals. So in this area, so we want people to be able to produce food and have good health, and then concern about energy and environment. Therefore, to contribute our work into something that can help with sustainability, it's sort of like some thing that we in as an engineer, we will have to think about it, like how can we contribute to the better world. That's why during the COVID year, so it's kind of interesting that with the COVID everywhere in the world, so we like for me, for example, after sitting at home for a while, I cannot go out. When I can go like travel around in Thailand, I start to visit different communities and talk to them and see like, oh, what's your problem? Like, how can we, how did we grow food? Because Thailand is a big agricultural country. Around Thailand, everywhere, we have different kind of farmer. So we don't grow only rice. It's like when people think about Thailand, we think about like we grow rice, we grow like rubber plant or like sugar cane or things like that. But in fact, there's so many farmers, small farmers that produce like things like vegetable, or like I visit like some goat farm, some cocoa farm. And that's when we connect to farmers and understand what's their problem and what's just the main thing that we need in Thailand. And when it comes to it, the way that farmer can be sustainable, usually because we have to reduce cost of farming. The problem is not about technology. It's not that we need to improve technology, but the real problem is that how can we reduce cost and make enough produce for consuming and selling. And that's a key idea, because when government go to like these farmers and say that, oh, we're gonna give you this new IoT system, we're gonna give you like smart cloud like solution, things like that. If the farmer has to invest or even has to pay for maintenance, it's not helping them, because it doesn't reduce their cost of farming. In fact, it's actually add more. So the solution for the longer term is that how can we help farmer to grow food at cheaper cost? And that's why I come back home and realize that what I want to do well, not the last part of my life, but more like in the next 10 years or 10, 20 years, is that I want to use my knowledge that I collect during like working in robotics to solve a lot of problem in farming and food production. And how can we make agriculture safer, cheaper, and good for environment? And that's a key idea. That's like, how can we roboticize the agricultural needs? So when doing that, let's go back to what is actually a sustainable food production. The sustainable food production is where the process of growing food and processing food, distribute food, consumption of food go like in circle. It's circular. That's mean if we can use the system that doesn't require a lot of external input, like if we don't have to import fertilizer, if we don't have to pay for petrol, how can we make that input like be like circular in the system? And with farming is possible, because plant needs soil, water, sun, and nutrients. Nutrients and microorganisms in the soil actually come from composting. So the way of organic farming or the way of regenerative farming, it will be good for sustainable food production, because this way, when you grow food, vegetable or fruit, you can actually use like a lot of agricultural waste. You can use food waste. All these go back into composting the new soil that more nutrition has had nutrients. And then when you harvest food, process food, the process involved, if you can introduce like clean energy, how can we like reduce the use of diesel? That will contribute a lot for food production and also distribution. And if we reduce the food, like the use of food packages, that can be like, if people can grow food in the local area, that way we reduce the use of plastic. And then if everything can be recycled, it can be circular. So I will show you how we did it at Raina Robot Farm. So it's like in the last part of my talk today. But the idea today is like, because we have so much knowledge now with robotic and automation technologies. If we look back like 20 years ago, we don't have these technology, but now we know how to make a good robotic arm and effectors. Like we can make like a smart, soft gripper, for example. We know how to make all-terrain mobile robot platform. And also the technology that use in robotics, like imaging technology, like RGBD, the depth camera, the multispectral camera. We have a very good now with the geolocation, which is like, for example, RTK GNSS, that more affordable these days. And we have technology to do like collision avoidance using LiDAR, using sonar. And also sensor or data can be connected with IoT technology. And we have the cloud-based data management. And also with power, a lot of improvement in the field of solar. So we can do like solar cell harvesting energy from the sun. We have the improved like battery management system, and we have improvement in terms of like what kind of batteries we can use with like lower cost. And in the last part, which is the kind of couple of years that people start to realize that AI has been advanced so much that you can use like computer vision or data analytics or like all kinds of like AI or machine learning algorithm to contribute with these solving problem. But what kind of thing we can solve in agriculture? How can we as an engineer help? So for me, I found that one of the problem in Thailand, number one, actually, like no one mentioned it, but it's actually a real problem in Thailand, is labor. Most of the food production in Thailand right now, especially like vegetable and like some fruit orchard, we use a lot of labor from neighboring country. So in the northern part of Thailand, we mostly like import labor from like Burma or Laos or even Cambodia to help with like the process of farming, planting, harvesting, everything. We import farmers. So during COVID, what happened is like people that used to work, the Burmese people in the north, they went back to their hometown, and we like a lot of vegetable farm has to shut down, and the vegetable price just goes up. And that represent how actually labor right now is one of the serious problem that no one talk about in Thailand, but it's actually happening. And the new, like a lot of young people, they want to do farming, but farm works the way it is now is so difficult, it's so like labor intensive. So if you want to go back home and do farming, you have to prepare to use a lot of labor work. And how are you going to solve that, right? And then also about energy. So in Thailand, almost 100% of the agricultural machinery are operated on like diesel engine. And direct cost is fuel. So you have to pay for fuel. So you have to pay for diesel, right? And that's like not only the cost of energy, but also environmental problem, because right now we have so much problem in like air quality, and we cannot reduce by just like stop burning. We have to reduce the use of diesel engine also. And it's like really big in agriculture because there's no alternative in Thailand. There's only like most of the machine are ICE engine. And also about health and environment, because a lot of food that we eat, people use because they don't have labor. So we resorted to solution that we're going to use pesticide, we're going to use a lot of chemical fertilizer to enhance the production. And that's in the long run is actually come back quite bad for both health of the people and the environment, because it's just no regulation. It's fertilizer is one of the highest cost of cost of farming. By doing that, I found that there are two ways that we can help. The first one is that how can we make easier and automated process instead of labor intensive process? How can we design a machine that good for soil-based regenerative and organic agriculture by automation? And I emphasize that word because I'm not talking about like plant factory. There's a lot of work in like America, Singapore, or other country that very urban, that they propose the solution like plant factory. But this solution is not good for Thailand because you have to import chemical, you have to import like all these fertilizer, liquid-based fertilizer, and you have to invest a lot in making all these system using artificial light. Why? There's no reason that we have to do that in the country that has good soil and good sun and enough water. Therefore, we should use like the basic, which is like soil-based growing, and how to make this process easy. And that should be a long-term solution for Thailand. The other idea is that instead of using diesel engine, how can we make agricultural equipment become electric power? Because with electric power, you can have a model where in the village, you share like a solar cell, and then that can charge the batteries, and you can use battery to power your equipment, your small tractor, or like some equipment like a pump. Things like that can be done all electric. It doesn't need to be diesel engine. And that's like, people don't see it. And one thing that I found with electric power machinery is that it's so precise, like you can control the way you control electric machine. It's more precise. You can do a lot of smart things. You can have sensor and you can actuate it precisely and with like low energy. And that's one of the very interesting part, that when I go to meet people, real farmer in the field, they don't see it. They get used to big thing with the tractor. They call it like a PTO head, which is like everything powered by engine of a tractor, right? And it's really hard to control speed. You cannot control like torque, or you cannot control these things because you have to do it all through like mechanical transmission. And by using electric, it's different story, because you can have like one motor for fertilizer spreader, one different motor for like mowing the grass, and it doesn't require the same speed or same torque. And that's the beautiful thing about electric power machine. And that's how I'm gonna show them. So now, after opening the company since 2021, so it's about like a year and a half, 2 years, I have 2 line of product right now. So the first line of product we call is that planter automation, which is like all electric driven automation system. The thing that I say is automation is because, for example, when you want to put soil in a bag, most of the system are like one bag, you hold it and then you like waiting to get the soil in. It doesn't have to be that way. We can automatically feed the bag and then fill it, and then having these like done automatically. So farmer can do other things. When the bag is full, then they can and use it to plant seed or to make like seedling. And then like we have the transplanter, which is like a kind of transplanting machine that you grow in the seed plot and you transplant it to a tray that you grow vegetable. And also this in the picture is the cocoa bean grading machine, which is a kind of grading, we use it to select the size of a cocoa bean before it's going to roasting. So that way we can control the quality of cocoa bean roasting better. Next, I'm gonna show some of the video. Let's see. So let me get back to the beginning. So this one is a cocoa bean grading machine. So we make it very low cost because it's like a prototype that we want to show it to the they call it the community, the cocoa producer community in Petrabun. So this one is built very cheaply. So this one is the continuous pot filler. So the grow bag would feed like one by one continuously. So it's like no human involved. And then it will fill by soil. And then, so this one, we collaborate with the asparagus farmer. So they want to do this when they start seed of asparagus, they do it in the bag. And then we grow this seedling in the bag before we planting in the field. And that's why, so we did this for the asparagus farmer in Thonburi province. Yes, so this is a kind of very quiet because it's all electric. Okay.
Yeah, Dr.
Yes.
Thavida, like what is the typical rate of production in that the last one, pot filler?
This one it's 14, then I forgot the number. It's like about 14 seconds a bag or something like that in
Okay,
the
okay, I
yeah.
see. Okay.
So it's slow because the design like this like one of the engineer they want to make it all like station. So if you want like faster production, it's actually better to do in like a kind of line of like
Right.
the what is that, feeder line. So this is like
Yeah,
circular system.
right.
Yeah, but it's cheaper with like one
Yeah.
one motor to
But I
like
think,
multiple things.
yeah, so 14 seconds, 15 seconds of 1 mean like you get four bags a minute. So that is also a good rate, I guess.
Yeah, something like that because their volume is not high. But I will show you later. It's like our company product, which is like the transplanter. That one is a lot faster. So it
Okay.
do like the seed tray. So the volume of the farmers also determine like what the speed of the machine should be. So okay, go back to the slides again. Okay, so the next group of products. So we have 2 line of product. The previous one is the planner, which is like things that stationary. The second line of product we have is the rover. So the rover is like the moving machine, moving robot that can use in the field. So at the moment we have like the first one is called Kating, which is like a small size. This one is actually can do like raft terrain. It's all-wheel drive robot. So we can use it for like spraying, monitoring, and things like that. So it's fully autonomous. And the other one is the Kokun, which is this one is a multi-purpose. So it can be like using for different purpose, and a person can also use it as the vehicle. So all these, it's we have the mission control software. So you can specify the path of the robot. So you can like specify the GPS coordinates of the field and the kind of path that you want to train it. Or you can actually drive it and then it will follow the path that you did before. And it has this visual navigation. So you can use some like guided Arugo code so that the robot can look at the code and can do like a specified task that it was like interpret by reading the code. So these are my line of autonomous robot. But from testing these robot in the Kokun prototype that we have, currently is a 2-wheel drive, battery electric, it's all electric, and it has 3 mode of operation, which is like manual, so I can ride it. So I can use it like a vehicle, like a small tractor, basically. But we equip with like multiple attachment. So you can use it manually, you can use it remote control. So it can be like remote, like the whole vehicle can be remote control, and you can also use it in autonomous mode. But the self-power equipment, which just mean all the mower, like we can do the front mower, the back mower, the tow bucket, and things like that, is all self-power. So it doesn't require like any power from the main vehicle. So you can power like this differently, and it's all electric. So it's very quiet. So in the video later, I will show you when it's done in the farm. But for the moment, this one is when we have the farmer test it at the palm oil. So this is like, so this is when the farmer use it for cut grasses in the palm oil plantation. The good part about this, after we learn of using it, is that with electric, so we have electric mower head and electric machine, the vehicle, it's a lot quieter, less heat from the engine, and small turning radius. And also with the front mower, like currently the farmer use a tractor with the toe cutter. So with the like a back cutter, like you cannot see it. So you have, when they want to cut around the tree, is quite difficult. So with this front mower, they can cut around the tree very easily. And that's one of the advantage of the design. And if you don't want to use it anymore, you can take the front mower out and you can drive the vehicle to the market or to see the farm, inspecting the farm. Therefore, here it come, like our first product as a mass production. We're gonna sell this as a product, which is a multi-purpose EV for farming. So the idea is that this vehicle, we just strip out the expensive part of the machine, which is the autonomous capability. So the product that we will sell now will not be autonomous, but this first product will be EV. So farmer can buy it, and we design it to use in either fruit orchard and for like, for example, like plantation like that, like in the video. And we not focus on, like we're not building this for tractor. It's more for orchard, for fruit orchard. So the needs that it has to be used is like mowing, so cutting grass basically, and fertilizer, so spread fertilizer to the tree. And also they can use it to towing, harvesting. And this product will be all electric, can have like a self-power attachment, so you can change the front, you can change the back, and it's swappable battery. So when the farmer wanna drive and power the pump at the like 5 kilometers away, they can do that. So they can power like the pump using this battery. So the vehicle would be small and lightweight, which is one of the advantages, because in Thailand it's very tropical country. And in rainy season, when you use like heavy machinery like a tractor, the soil would be, well, it's not only impact the soil, but it's like create the groove in the orchard, and that's not good. So the lighter vehicle wouldn't have that problem. So you can cut grass even after the rain, and it's easy for maintenance and reduce noise and pollution because it's like quiet. You don't really have to drive like when you drive a tractor. Usually in Thailand they still use like a manual tractor, so you have to keep one leg on the clutch, the other on the brake, and things like that. It's really difficult or kind of painful to cut grass for like 4 hours. But with this electric, it's very easy. Like you just put your feet on the ground, you don't really have to do much, and then you can have like you can hit the brake with your feet, or you just like go slowly, for example, and it's a lot easier to control. And also you can like have a solar cell, like an off-grid solar cell, solar charger, and it's affordable. And that's the main thing. So we target this product, which is like half price from a smallest tractor in Thailand. And the other project that I currently like do and proudly presented is the concept of Raina Robot Farm. So Raina Robot Farm is the farm, the demo farm that we built, the real farm in Bang Mot area in Bangkok. So it's the circular organic vegetable production, which is like the idea that I say in the early slides, that vegetable production or food production can be entirely circular. Why is circular? Because why is difficult? In Thailand or other country, problem in urban farming is that you don't have space, you don't have labor. And also like there's a lot of like when we buy vegetable from a market, now it's all plastic, packed in a plastic box, plastic bag. And there's a lot of waste, like plastic waste. So at Raina Robot Farm, we have a new concept that we're gonna produce and sell a living vegetable in a container. So we don't sell like the cut vegetable. We sell the whole vegetable in a container, like a pot or a bag. And that way, when customer buy it, they can either like cut the whole thing and eat it right away, or they can actually just take some part. Like if you buy like a chili plant, for example, it can last like a couple months. I mean, you can just pick like when it has chili, and then you wait and then come back again. Or when you eat like kale can last for like a year if you pick it and put it by the balcony, have some sun, have some water. So the vegetable, like one plant can last for a long time in the container with soil. And by doing that, some people might think, wow, it's so difficult. Like why we have to buy the vegetable in a container? But we want to introduce people to concept of that they can grow their own food. But if they don't want commitment, we have the program that we can buy back container and soil. So when you finish eating it or when the plants die, you can bring it back to the farm and we'll buy it back. And then we compost the soil, we're gonna recycle or we reuse the container. And everything is done by electrical power system. So all the machinery is like electric power, which is like quiet. to be like when you put it in the urban environment, it's quiet and it doesn't produce a lot of air pollution. And that gonna come back into soil. So all the process will be have soil, we reuse the bag. So nothing waste, everything 100% going back in circle. And that's the idea of the farm. So at Raina Robo Farm currently, so we have like the process, like shedding, mixing soil, put it in the bag, the pot. We have the transplanter. We have the rover that can help in the farm. So it's a demo farm that we can show people that how these things work. So this one, I hope that so this is the transplanter machine at the farm. So the machine will transplant like, so this one we prepare soil in the tray and the vegetable is in the seed plug. So when the seed plug is loaded, it will be transplant into the tray. So after the vegetable is transplanted to the tray, we will transport this tray. So the next tray, set of tray will come in and the tray will be transported. So this one is not fully like robot. So we have human farmer. So farmer will load it into a robot. So the robot will take it to the planting station. So this one is from the transplanter. So the robot will navigate it to the area of a grow area. So in the grow area, it will, so it's gonna navigate it there. So and then, so the farmer just unload the tray. So this one. So the farmer will like unload the tray to the growing area. And in the growing area, we already install like the watering system, like sensor system, so that we can detect the state of the growing. And by doing that, so we actually know when the vegetable is ready for consumption and like how many plants ready to be sell. So this is the Raina Robo Farm that we do the pilot farm and in Bangmot area of Bangkok. Okay, so that's it. So that's that's my little project called Raina Robo Farm. And so with the Raina Robo Farm, we have an application that you can actually select the ready vegetable and you can actually collect credits when you return the vegetable. And also people can volunteer their time and they can collect credits so that when they purchase the produce, they can have like a lower price by doing work. So in the apps, you can keep track, like you can only help in the farm for like 15 minutes, or you can help like the farm like 5 hours, and that will contribute to your credit to buy vegetable. So this is Raina Robot Farm. So if you guys have a chance to come to Bangmot area, so this is where we are next to Rungarun School in the near Rama 2 area. So this is the actual farm location. And this is I want to show people that we can actually create food in urban community. And everyone, the idea is that everyone can grow vegetable, because like when you young, like if you young, if you woman, if you like not strong, like you might have health problem, you can still be part of the farm. You can help a little bit. So we can use these activities to sort of introduce people to like how to relax in nature. And kids can also at the farm, they can also see actual like agricultural innovation that is all like 100% designed and built in Thailand. And it become a learning space for both agriculture and technology, and also show that the cost in vegetable production and waste, instead of like buying bags that you have to throw away, those plastic bags that you put food in, you don't have to do that anymore. And that will reduce the cost in like production and when you keep in the fridge, you don't have to use energy for that because you keep it in the soil. So that change the behavior of people when they consume vegetable in urban area. And that's what we want to achieve. So this is the actual farm. So if you guys want to come visit, just let me know. So we have the Facebook, we have the website that is not very informative at the moment, but yes, so you can contact us at Raina Robotech. Yeah, so it's about 1 hour my talk. Any question so far?
So thank you very much, Dr. Thavida, for your informative presentation, and it was very interesting, I think, for the audience as well as myself. So thank you very much for the nice presentation. Basically, it's up to the audience now. It's up to you to raise any questions that you have. You can unmute yourself and ask any questions from Dr. Thavida, or else you can type your question at the chat box so that we can try to answer for some time. Meantime, I'll just ask a few questions that I have with me. So Dr. Thavida, can I know like what sort of collaboration do you have with the universities as an industrial institute? What sort of collaboration do you have with the universities?
Oh, it's like we have a very close tie to the university. So the continuous grow bag filler that you see, the system is done by one of my students that he did it for the work integrated learning program. So the student can spend time at the company for like 6 months, and they have the project. So I pay them as an internship.
Okay.
And they work in the company, but they develop this product for the company, but it's like also go back into credits for their class. And I usually like recruit a student from 3rd year. So if they want to do like a short-term internship, like 2 months, or long-term, like 6 months. And that's why we get like a really brilliant engineer after graduate. So when they work and then they understand like what's the vision of the company, if they like it, they usually join us so that like they become my full-time engineer after graduated.
Okay, very nice. So then the other question is like, how do you usually find the investment for these product development like over the years?
Huh? Well, can you say that
So
again?
yeah. So how do you find the investment for the product development at your company? Like, what is your investment source to begin with?
Okay, so in this question, I'm very like a bit unusual. Is that my business model is bootstrapping. So I invest entirely from my own money. and it's the way that I'm gonna push it. That's my personal belief, that I'm not at the moment, I'm not asking for investment for VC or anything like that. I don't call my company like a startup, because I actually more like an SME, small medium enterprise, but we are like in Thailand we call it SI, system integrator, but just more focused on only agriculture, SI.
Right.
And oh, there's one question. Can I ask? Can I answer?
Yeah, please go ahead. Yeah.
So most of the technology I use, it's basically low cost. Like a lot of things that we did in the farm, in the robot, we just use, like, for example, ESP, but modular ESP, which means like we in like one robot, like for example rover, we might have like 5 ESP inside that control different things and sense different things. So I use like a low cost microcontroller, and sometimes has like, depends on the requirement, but if we use vision, so we have like a more kind of CPU, like a embedded CPU, like single board CPU to process the visual data, and then the rest like control, motion control, or the one that deal with the RTK GNSS would be processed through like a packet. So everyone, my design is very distributed, and I don't use RAWs. I just learn from them. So that's one thing that I'm quite different, because I'm entrepreneur. So my software, I don't really rely on a lot of platform. We develop in-house library. So when we don't even use OpenCV. So most of the vision we kind of write it from scratch, and the RAWs, I just learn it like by like how can they develop the architecture, but then I have my own like, so I have my own protocol like we call like a MIPC server. So it's like a distributed design, so that when one machine down, the rest can be like still function. So it's a very specific. So if you want to learn more about that, I can explain to you, but it's quite detailed. So we designed a communication layer, and we also use the low cost RTK GNSS. So we built the base station ourselves, and we didn't buy a lot of like ready-made product, because we want to make everything low cost and affordable for Thai farmers. So we use commodity hardware. We use webcam on the robot right now, the rover. We use webcam. We don't use like expensive like a 3D. Like I know how to use them, but it's not good for the price. So everything we build, it has to be able to sell. So I cannot sell like a 2 million baht robot for Thai farmers, but I can sell these, like my new product. I target is about like 150,000 baht, which is like reasonable for Thai farmer. So every product we do, we compute what is the return of investment. So it has to be reasonable, like 3 years, not more than 5 years for sure.
Professor Maheshi, you have a question, please go ahead.
Oh, yes.
Yeah.
So you saw the article tag. Wow, very good. Yes. So like I said, so I use these article tag to basically, we sort of have a code built in with that. Like when the robot see it, it will know the location and also know the sort of command. Like the certain tag will mean it has to align in the middle. A certain tag will mean that, okay, and don't go further than that, or something like that. So I don't use the article tag the way that a lot of researchers use in visual odometry, because in real life, if we're gonna use for localization, in the farm, we deal with like, how many, like in Thai, we call it in rai. So one rai is like 400 square meters. So in the large farm, you cannot have argo tag like every like 1 meter. It's crazy. You cannot do that, right? So we only use it to guide. So together with the GPS, we have the RTK GNSS, so it's more precise. So the accuracy of localization, it go down to like maybe 10 to 40 centimeters. And then we use vision to adjust it to be like more precise. But we don't use pure, in robotics, we call it like, we don't use V-SLAM. We don't use all like visual SLAM for it. It's too much computation and too many tag needed.
Okay.
And we cannot use the navigation package in ROS because most of them are very designed for indoor localization that based on LiDAR. So based on point-based localization, which is doesn't make sense in the field because when you see like mango trees, they all mango trees. They look the same.
Yeah.
And they're like,
Absolutely.
they move by the wind. You cannot use like point matching algorithm at all. So that's why we have our own in-house. So it's a layer of GPS localization together with visual. And IMU, I forgot to say. We also use IMU to help with like the localization.
Right.
Oh, okay. What is that? Another question. What is the sensor? Oh, the second question that he asks is the robot always looking for a tag by navigating? Okay, we pre-program where the tag is in the map. So the robot know itself roughly using GPS localization. So with that accuracy, we get like about 10, 40 centimeters, depends on how far to the base station. And from that, it will look around for the certain zone with the argo tag. So it will know that, okay, in this area, I was expect to see these tag and what is it that this tag tell me? And it will do something like it would try to align or it would try to go like 50 centimeters on the left side or something like that. So that's how we use. And what is a sensor and method that prevent for collision between robot and farming station? I mean, currently, I have the LiDAR, but I also kind of mostly program like pre-program the path by human so that it has the walkway. But with the close proximity, like if something ran across it, it will stop by LiDAR. But it's a low cost LiDAR, so it's not like a 3D, it's like only 1D LiDAR.
Okay.
Okay, 4x-based application farming will be more beneficial to integrate PLC. Oh, it's all PLC on the one that you see. It's all PLC based system. So the transplanter, the soil, like filler, is all like PLC system.
Thank you. So Professor Mahesh Disanaga is also here, who is a former chair of IEEE Sri Lanka section as well, and I think he served in some art and committees as well. So Professor Mahesh, I think you had some questions. Would you please go ahead and ask?
Thank you. I think actually the second question early in the chat answered that one. I was going to ask, how do you manage collisions and kind of like keep the robots in the environment hazard free? So you answered that one.
Oh,
yeah, thanks for that.
Yeah. Okay, nice. So basically, okay. Right.
hello, Akila. Thank you for inviting me.
So I have one more specific question, Dr. Thavida. Like basically, can you tell me like who are your major clients and how do you reach out to the clients to market your products, basically?
Okay, so I have two line of product. The planter line, We actually now have like one of the client is like a big vegetable producer in Thailand, but at the moment they told me not to tell anyone. So I cannot tell you the name,
Okay.
but
Okay. No issue.
yeah, so Thai people will know it. So they're one of the big producer in Thailand.
Mhm,
So
mhm.
they have a large volume. But the other cider product, the Rover, currently the Rover one, we will plan the first market. It's in the group of like palm oil plantation. They call like in Thailand, it's called a large plot group. The idea is that when it's kind of weird name, but it's kind of like agricultural co-op, but different. It's like they basically in the same province, then they grow the same stuff, right? So they have their own farm, but they share the cost of the certain things like equipment or some like funding from the government. So in Thailand, it's called like a large plot size group. So when so they don't, each individual doesn't own like large land, but smaller size. So when they use my EV, so I have the agricultural EV for them to use, then they can basically buy it as a group and they can like sort of rotate. And they can also in the future, hopefully that I want to introduce the solar, like off-grid solar charging station for this so that everyone can share energy and equipment.
Right. Right. So how do you like how many people do you employ at your like Raina robotics company? Like how many staff members do you have typically at the moment?
How many staff, right?
Yeah. Engineering and all like everything. all
Eight
together.
people.
8 people. Okay.
Yes.
Okay.
Still small.
Yeah, but you're doing
Yeah, I'm
a
quite
great job.
conservative because I use my own money.
Right.
So we don't even have like, well, we work in the tent.
Uh-huh.
So all my engineer develop all these robot in the tent with no aircon. So hopefully it's not too hot this year. I feel bad for them. But I want to test and build a machine in the real environment because in the
Right.
farm there's no aircon. So
Yeah.
most of my engineer has to like get through the heat of Bangkok.
Right. Yeah. So finally, like if I ask how can we collaborate with you as one as Sri Lankan universities or two as Sri Lankan industry, say either electronic or agriculture, or on the other hand, or even as a farming client?
Yes. I mean, I'm open for all collaboration. You can, I mean, if you interest to send a student to intern with us, or
Yeah.
if you have a certain like problem, I can also like co-advise them from like online if it's like too difficult to travel. So I mean, I can share some of the experience because Thailand and Sri Lanka has a lot of like same what do you call, like we sort of in the tropical kind of zone.
Yes.
So you
Yes.
guys have coconut, like all the produce are quite similar. So
Right.
that's why and plot size are not big.
Yeah.
So we have the same problem.
Yeah.
But the technology, I mean, it's like available everywhere. Like you can buy all these electronics, but most of the problem is about like how can we make it reliable and resilient.
Right.
Like how, like for example, like I spent the last year building this base station for my RTK GNSS. So I have to do so many things like heat proof it,
Mhm.
insect proofed it. In Thailand, we have a lot of problem with like
Yeah.
insect get into the electrical box. We have problem of like rats eating wire.
Yeah, absolutely.
So things like that. So I have a lot of know-how to deal with all these stuff. So it's like
Okay.
if you guys have like run into the problem, yeah, we can
Mhm.
share the solution. It's like sometimes it's just kind of funny. We just like put in some little things to block it or
Right, right,
yeah.
very cool.
So I hope that people can learn something today. I just
Yeah.
want us as an engineer know that we can contribute to the world by using our own expertise. Because sometimes like when I go into this field, I used to think like, why would I do that? Like there are agricultural engineer people. Why would I take their job? But it's not true at all. They were trained differently.
Mhm.
They look at the problem in terms of mechanical solution. But when I see a problem, I see from different angle. So we need to collaborate, not competing.
Right.
And there's so many problems in the world that the more people work on it, the more we have better chance to solve it. And that's why I mean I'm open for collaboration in just like physical like work or idea. I mean I can help if people want to do this and want to share like what do I think about this. I can talk to you guys, no problem. The world is like so close now that we have online.
Absolutely. Absolutely.
Yes.
Yeah. Right, right. Thank you. Thank you very much, Dr. Thavida, for that nice words as well. So we hope we can have more collaborations in the future. So maybe IEEE itself could be a platform for us to join with each other and
Yeah.
have more collaborations. So hopefully we can get some, some
Yes,
university
yes.
students to you as interns in the future. That would be a good thing. So we can share that information with the students mainly.
Yes.
And all, yeah.
So
Thank you so much. So I would say, yeah. So if there are any other questions, I think we can basically
I
wind it up.
gonna type my email in the chat.
Sure,
So
please do.
if
Please do.
anyone want to contact me directly by email, just yeah, please do.
Right.
That's my nickname,
Yeah,
Crowd. So yeah, so just send me email so I can see what I can do with you guys.
Right. Very nice. Thank you very much.
Okay.
Okay, and then I would like to, thank everyone who joined with us today as well, from Thailand, from Sri Lanka, and from maybe any other place in the world. Several people have joined with us and stayed towards the end. Thank you very much for your support and collaborations. And I would like to finally thank you once again, Dr. Thavida Maneewarn, for delivering this nice speech and a very informative speech, of course, because it's kind of, I myself is pretty much interested in smart agriculture and high-tech agriculture personally. So this was a very good eye-opener for myself as well. So I'd like to thank you once again from IEEE Power and Energy Society Sri Lanka section, Sri Lanka chapter, as well as IEEE Industrial Electronics Society Sri Lanka chapter, and also from the IEEE Robotics and Automation Society Sri Lanka chapter. Finally, I would say Kapun Kap.
ขอบคุณค่ะ and I hope that I can see you guys in person in Sri Lanka one day.
Of course. Just one moment, I'll just take one final snapshot of this event where people is present. And yeah, so thank you very much, everyone. Hope to see you in the next session of the webinar pretty soon in the coming months. So have a good night, everyone. Thank you.
Okay.
Okay. Goodbye for now.